Hello and welcome to this quick take video where we'll be discussing the new features in Vivado Design Suite 2017.3. There are a number of enhancements in Vivado 2017.3 and this short video will cover some of the highlights in different categories. Let's start by looking at the high-level enhancements first. Vivado 2017.3 is now supported on new versions of Red Hat, CentOS 6, as well as the Creators Update for Windows 10 operating systems. Additionally, it is important to note again that 32-bit OS support has been discontinued for all editions, including Lab Edition. As always, please refer to the 2017.3 release notes for supported versions. Zynq UltraScale Plus MPSoC and Kintex UltraScale Plus devices listed here are now in production. Additionally, Zynq UltraScale Plus MPSoC EV devices, along with Spartan 7 and Arctic 7 devices shown here, are all in public access. In Vivado 2017.3, the installer provides users with the ability to select the compilers for different processors. Note that they are all selected by default. However, by using this compiler selection option, users can now benefit from some reduction in the disk footprint required for the installation. In the area of licensing, starting with Vivado 2017.3 release, activation licensing support has been removed. Therefore, all the features supported by activation licensing are discontinued, including license borrowing feature. In addition, all of the existing activation licenses have been replaced with certificate-based license that can be accessed from the URL shown here. Flex licensing management tools have also been upgraded to 11.14.1 version. As a result, if you are using floating licenses, then you must upgrade licensing utilities to Flex 11.14.1. All of the new licensing utilities can be found on the download page of Xilinx.com. It should be noted that if your license file is under 1 year old, then it is expected to work with Vivado 2017.3 after you upgrade the licensing utilities. One of the GUI enhancements introduced in this release is the customized reporting feature. This enables users to run various reporting commands at different stages of the design flow. A new report strategy mechanism allows you to create synthesis or implementation report strategies. This way, you can choose which reports to run after each step and apply them to runs. The project settings also have new options for report strategy under Strategies section that allows custom report strategies to be created and reused in addition to default strategies. New support has been added for report bus queue constraints under the Timing Report section of the Tools menu within the GUI. This feature allows better analysis of these constraints and enables direct cross-probing to paths, reference paths, or constraints. As part of the improvements for the text editor, a Find Usages feature is now available in the options provided by right-click on the text. With this feature, you can jump to signal and constant declarations and determine where constants are used. Additionally, the tooltip feature now shows the definition of the constant values when the mouse pointer is hovered over them anywhere in the code. For partial reconfiguration and Tandem features, all of the UltraScale Plus devices are in production status in 2017.3, and that includes all of the UltraScale Plus devices in production for Tandem and AXI stream cores. In project mode for PR, any of the IPs in a reconfigurable module can now be synthesized in OOC mode. PR controller IP now has a new bitstream compression option to compress PR bit files anywhere between 30 to 70%. This algorithm is different from what is being used for write bitstream and the configuration engine. And there are enhanced example designs for UG947 and Tandem with field updates designs. In IPI, the feature to integrate the RTL modules into the block designs can now be done by drag and drop from the sources window. Also, there is no need to run the packager anymore in order to integrate RTL into BDs. The ability to add RTL modules as reference modules in the IPI has also been extended to include a much larger group of IPs. There are some, however, that are not supported within a module reference, as you can see in the list here. In addition, IPI now provides a pop-up menu command called Save BD As. This enables renaming and externally saving a BD from one project to another. In IPI, users can now easily launch HDMI or MIPI example designs by doing a right-click on these IPs on the canvas. There is also new support for ZCU 102 and 106 boards for MIPI and HDMI examples. For IP flows, write project tickle and write BD tickle functionalities are now combined into one. Vivado also makes sure that all necessary repositories required to recreate the design are now included and referenced in the generated write BD tickle script. This pre-check lets users know if any reference IP needs a repository and issues an error if any of the IPs are not found. Additional board awareness and designer assistance are now available for hard 100GE and interlock and subsystems for VCU 118 UltraScale Plus board. There's also added FMC connector support for ZCU 102 and 106, intended to extend the target board selection process for FMC cards. Moving to XPM IPs, XPM FIFO now has added new optional flags for almost empty, almost full, and read data valid. And XPM memory allows you to specify different read and write widths while still using the byte write enable in combination. In the area of simulation and verification, we now have the production release of the AXI Stream VIP. The AXI Stream VIP provides full AXI protocol checker support. It implements ARM license assertions. It is designed in SystemVerilog and is license-free. For PCW, there is a simpler interface available for DDR configuration with the addition of presets for a number of memory parts. For clock configuration, there is support for fractional clocks now. This is supported for DisplayPort audio and video peripherals and potentially can reduce BOM costs. Additionally, address fragmentation for PSPL configuration has been enhanced. This is intended to reduce fabric utilization by making use of PS resources. SystemVerilog now has support for the MATLAB versions listed here. In addition, block memory and FIFO generator IPs are now used for RAM and FIFO blocks. This essentially allows access to the latest version of these IPs within the Simulink environment. This update applies to single and dual port RAMs, ROM, FIFO, and AXI FIFO blocks. SystemVerilog now also offers enhanced error messaging for all of the high-level blocks that have AXI interface. There are a number of improvements and enhancements for synthesis in Vivado 2017.3. Hierarchical path names and case ranges are now supported for Verilog and SystemVerilog. And new attributes are in place to control register retiming and auto pipelining. Let's look at these features in more detail. The capability to use hierarchical path names allows users to access signals from other instances. As shown here, the tool automatically creates a new port for the lower level module and connects it to the logic. Here we can see the temp port automatically added to the U0 instance of the module as indicated in the RTL. Case ranges are now supported for SystemVerilog. User can specify a range in case statements as shown in the example here. It should be noted that the range must be used with the inside statement. New retiming attributes can now direct the tool to selectively move registers backward or forward from the original position. It should be noted that registers only move one level from the original position as shown in the example here. Automatic pipelining can now be applied as part of the block synth property. This feature adds registers to improve timing if more registers are available. It detects the critical paths with greatest number of logic levels, adds pipeline levels to be pushed into logic, and then balances the logic for the best performance. For implementation tools, here are the major highlights of the main features. In logic optimization, OpDesign now provides fine-grained conversion between SRLs and registers for flexible pipeline register implementation in high-speed designs. The carry remap optimization now only converts single carry chains by default to avoid massive timing failures while still maintaining fine-grained control. The remap optimization now works across logical hierarchy to further reduce logic levels. And the equivalent driver merging optimization avoids merging obvious cases where replication is needed, such as equivalent driver in different P blocks. For physical optimization, a subset of Vivado Design was included in the placer and became known as PSYP in 2017-1, short for Physical Synthesis in Placer. This gives better performance in 2017.3 as many outliers were analyzed and fixed. There's a new directive, Runtime Optimized, where Vivado trades some QOR for faster runtime. Overall, Vivado should cover all possible optimizations in a single pass such that successive looping is no longer required. There's also an advanced hold fixing option to insert negative edge triggered registers to fix hold violations. A couple of new features in Placer include the edgeLOT-NM property with the keyword of disabled, now preventing the Placer from combining individual lots when trying to fit a highly utilized design or P block. Up to this point, there had been no control over Placer lot combining. This is important mostly for debug and ECO flows. Also, using a net property called clock low fanout on a global clock now directs the Placer to confine the buffer and loads in the same clock region. This will be eventually added to the clocking wizard for the safe startup option, but in the meantime, the property can be manually applied. In routing area, the TNS cleanup option of the router is now re-entrant. In the past, the router would route from scratch with this option, making it very difficult to improve TNS with successive runs. Now, existing routing is contained when running TNS cleanup. Incremental compile is now more reliable in choosing between high versus low reuse modes. There have been miscellaneous enhancements to report design analysis as well. Notable additions are in the logic levels reporting. There are new options to replace logic levels with routes, which tends to be more representative of the critical path. Options to specify the bins for logic level reporting, and in the GUI, the logic level report table now is hyperlinked to allow drill down analysis into each logic level bin. Report QOR suggestions, or RQS, was introduced in 2017.1, and the set of QOR checks has been expanded in 2017.3. Particular areas of improvement are congestion and high clock skew. RQS now skips the suggestions applicable to the items inside the Xilinx IP, which are out of the scope for user intervention. And a new option called Report All Paths now shows all the paths that apply to a particular check in the detailed report sections. As part of the new features for power analysis, users can now export an XDC file from XPE that contains the environment settings as set operating conditions constraints. XPE GTY IP offerings now include all available configurations. There's also added support for what-if analysis for powering down GTs and their PLLs separately. A maximum power budget can be specified for reporting power using set operating conditions. Report power will then report against this budget, making it obvious to see whether or not the budget is exceeded, similar to timing slack. New settings in the schematic viewer display switching activity for scalars and buses. And finally, a yellow banner now appears over power reports when there is a change in power constraints similar to the timing report feature. For SDA, just a couple of enhancements. Clocks are now exposed as objects inside report methodology GUI, and they can be cross-probed. Report CDC now returns CDC violation objects similar to report methodology and report DRC. For incremental compilation and simulation flows, until now, we were storing simulation database in one common directory and were cleaning it up on relaunching of the simulation. Due to this, third-party simulators were not able to take advantage of incremental flow that they have supported for years now. Now there's individual folders for each simulator to maintain the simulation database. Therefore, if incremental compile is selected, then the tool will not clean up the simulation directory. Verification IP is now included in the simulation library. This is a versionless VIP library that will protect users from updating their verification code when IP version is changed. Note that any project that uses AXI VIP will reference Xilinx VIP automatically during the simulation. SystemVerilog enhancements are listed here. They include support for fine-grained process control, parallel blocks, wait fork, array locators, and other capabilities that you see listed here. There is also new support for VHDL 2008 operators, including matching relations, unary logical, and binary operators. For hardware debug, the replace debug probe capability in ECO flow has been enhanced. With this new process, there's going to be improved QOR after replacing the ILA probes. This new command replaces and routes nets in one step and leverages physical synthesis place and route to improve QOR, especially if pipeline stages are used for ILA IP. Additionally, there are a number of enhancements to XVC solution for remote debugging. In particular, there are now additional support for example design generation for debug over PCIe. XDMA PCIe IP can now generate its example design with XVC feature for both UltraScale and UltraScale Plus devices. Same support is also added for UltraScale Gen 3 PCIe block. Support for MDM is added to enable microblaze debug via SDK using XVC, and new support of switching between JTAG cable and XVC along with fewer restrictions in PR flow. For programmer, we have the SmartLink cable in production. This new cable offers faster programming and debug by operating at a higher clock speed for JTAG, and it also supports USB 2.0 or Ethernet connectivity to the host for easier remote access debug. New support has been added in SDK for programming eMMC flash devices for Zinc MPSoC, and a new method for storing eFuse settings is in place to improve the operability of the third-party programmers. So in summary, Vivado Design Suite 2017.3 contains support for new devices, supports new SmartLink cable for faster programming and debug, expands design analysis capabilities and QOR suggestions for implementation tools, offers customized reporting and strategy support in IDE, and provides additional ease of use by adding MIPI and HDMI example designs in IP Integrator. Please review the Vivado 2017.3 release notes for more details on all the features and enhancements. Contact your local Xilinx representative today for more details on Vivado Design Suite 2017.3 or go to www.xilinx.com/download to download and install it today. Thanks for watching.